Question 12, Part F. Milk taken out of a refrigerator has a temperature of 2 degrees Celsius. It is placed in a room of constant temperature, 23 degrees Celsius. After T minutes, the temperature, capital T degrees Celsius of the milk is given by capital T equals A minus B times e to the power of negative 0.03 T, where A and B are positive constants. How long does it take for the milk to reach a temperature of 10 degrees Celsius? This is an application of Newton's law of cooling. Recall the model capital T equals A minus B times e to the power of negative 0.03 T. Now I'm saying capital T because the lowercase t here refers to time. So when I just say T, I mean time T. Now initially, capital T equals 2. So the temperature is equal to 2 degrees Celsius when time T equals 0. Substituting 0 for T here, we get e to the power of 0, which equals 1, and b times 1 is b. Hence, a minus b is equal to 2. I'm going to call this equation number 1. Now, long term, in other words, for very large values of time t, as t approaches infinity, in other words, capital T approaches 23 degrees Celsius, which is the ambient temperature of the room. Now, if we substitute infinity, or a very large value of t here, e to the power of negative infinity approaches 0, and b times 0 is 0. So in other words, capital T approaches A. And we know that capital T approaches the ambient temperature of the room, which is 23 degrees Celsius, hence A equals 23. So if we go back to equation number 1, we've got A is equal to 23, 23 minus B is equal to 2, so B is equal to 21. Hence the model is capital T equals 23 minus 21 times e to the power of negative 0.03 T. Now we need to solve for T when capital T is equal to 10. So 10 equals 23 minus 21 times e to the power of negative 0.03 T. We can rearrange this equation somewhat. So if we subtract 23 from both sides of this equation, we get negative 13 is equal to negative 21 times e to the power of negative 0.03 T. Dividing both sides of the equation by negative 21, we get the double negatives here, which will become positive. So we have e to the power of negative 0.03 T is equal to 13 over 21. Taking the natural logarithm of both sides, and that'll deal with this base e here, we get negative 0.03 T is equal to ln of 13 over 21. Finally, we divide both sides of the equation by negative 0.03 to get T as the subject. So T is equal to ln of 13 over 21 divided by negative 0.03, and that evaluates to 15.985 and so on minutes, which rounds to 16 minutes, correct to the nearest minute, for the milk to reach 10 degrees Celsius.